Hello, my name is Pia. I'm from Herodotus. I'm product engineer in Herodotus. Today, I'm gonna present about what is storage proof and what storage proof can solve, and so what is storage proof and what to Herodotus is abstract the storage proof. Yeah. So before we jump on, we need to discuss about what kind of problems that the storage proof solve. We have to think of what is the Ethereum's current state. Before, we store the data like contract address, storage key, and value inside the Ethereum. But we are missing the one dimension, which is time. What if we can actually get the specific contract address, storage key value at the specific block time number? Which is now this dimension is lack of current Ethereum state. Okay, so the second one is, as you know, when the Ethereum goes more sharded, we have a lot of scaling solutions like L2s and rollups, which is Starknet is one of the one, and which means that we have more options to store the data in inside the A rollups, B rollups, and there's many cases that we need to access for each rollups. So actually, what we think of it, even though the database is more sharded, we have to access the data, whether user have to access the data regardless of the location is the data. Yeah, regardless of the data is stored, right? So basically, current Ethereum has two major problem, which is time and space. Which is, we believe the storage proof is the best solution that can solve this problem. So what is the storage proof? Now let's move on to more technical discussions. To understand what is storage proof, and understand that what storage proofs then unlock the historical data that we just mentioned about the problem of the time. We need to understand that storage proof enables you to unlock verify the whole historical blocks based on recursive proof. So you can basically retrieve the previous block hash through the current block hash, and you can retrieve it again and again and again until go through the Genesis block. And this part we discussed at the San Francisco Summit, which is a few days before. We announced a big announcement about we can able to borrow the Starkkware Sharp as a first external team, so that we can able to make an off-chain processor to process the whole Ethereum blocks from the almost latest blocks to until the Genesis block, which is crazy. So that means storage proof enables you to access the data from the Genesis block to the latest block. We're doing some, we are accumulate the block hash of the L1 through the certain checkpoints. So it will be pretty cool. Yeah. And then second basic knowledge to understand the storage proof is a Merkle tree. As you know, Merkle tree is you hash the data and then you hash it again and hash it again all the way through you go to the Merkle root. And why this is important is because if you know the Merkle root, then you can, when you get the Merkle pass, which means if you have a data A, and if you have a Merkle root, then Merkle pass, which is to retrieve the A from the Merkle root, itself is a Merkle inclusion proof. Itself is, we can prove that A exists in this Merkle tree. It's a basic knowledge to understand the storage proof. Okay, so now goes through the storage proof 101, which is core concept is I just mentioned, briefly. You can prove any kind of data that exists inside the Merkle tree, and based on the cryptographic commitment, which is right now the Merkle inclusion proof. So let's move on to this page, and which you can see in the block header, you can see multiple roots. And let's go through the state root. And state root contains the state tree, which is state Merkle-Patricia tree, which stores the every account as in element. And if you click on one account, which is you can think of the wallet or you can think of the smart contract, then you can see the nodes balance storage roots like code hash, and the storage root is the root of the tree, which stores the every values that's stored inside based on this contract. So this is bit tricky. This is how the Ethereum stores the data inside their blockchain, and these steps is the reason why we're abstracting this storage proof in the API and to the Turbo. Okay, so just to recap, if you want to access the specific value of this storage tree, then you have to calculate the Merkle inclusion proof of this value. And then this account state itself is also stored inside this word state tree, which is also a Merkle-Patricia tree, which need to calculate the Merkle inclusion proof, which you can retrieve from the state root. And it needs a two-step of Merkle inclusion proof, which is pretty expensive. So that's because that's the reason why we are, as Herodotus, we are building the API and we are building the Turbo, which is one-line query to access the data from the another chain to another chain using storage proof. And we use some ZK Snark and Stark to read and write more efficiently and to store the block headers using the off-chain to make the cost more cheaper, so that actually user can use our infrastructure on their application. Then you can maybe ask why this is useful. Then we can just say there's many use cases, of course. One of the use cases that we are talking with the SnapshotX is we can actually do the cross-chain voting using storage proof. You can make a proof of the asset, and based on L1 asset, you can do the voting on the L2. And also you can do the identity. You can use your ENS on the Starknet, and you can do bridging. You can use your Ever AI on the L1 to the Starknet. And gaming, you can use your L1 asset and make a proof and execute and make a transactions on the L2 game. In this talk, I actually recently prepared the demo page to showcase how to call the Herodotus API in the more intuitive way. So this API is basically abstracting the process that I just mentioned, very technical part, so that developers don't need to think about the Merkle inclusion proofs or ZK Snark and Stark, etc. So what you need to do is first, you just need to think about where you want to generate the proof and where you want to use that proof. So in our case, right now we are supporting the Gorilla to Starknet or ZK Sync. In this case, I just start Starknet. And then what block number you want to generate the proof, which is you're mentioning about the L1 block. So currently, our API itself, we have a limitation of about 250 blocks, but this one will be changed soon because of because we are borrowing the Sharp and verify the L1 blocks until the Genesis block. So you can call the block number 0 soon. But now let's do the almost latest block. And what you want to prove? This part is the part that I just mentioned with the block headers and then like stage tree, etc. You can access to the block header, which you have these options like block head number hash parent hash, all the data that you can access through the block header. You can literally make a multiple proof using our API. And the account, which is you just need to put the account contract that you want to access. Right now, I don't have my wallet, so actually, you can put the ENS in here also. We support the ENS. And yeah, of course, you can add the multiple but the thing is, if you want to do the storage hash, you need to put the Merkle inclusion proof of the specific value inside the storage tree, but this part is, I think, not enough time for this talk, so let's just do with the block header. So, yeah. Just you can do whatever, and then if you want to get the response by the webhook, then you can put your webhook URL, then you can get the response back to your webhook. Or if not, then you just you need to submit the API key. Which is API key. You can get the API key by the GitHub. Which is, I don't think this is my laptop, but I think it's Gil. Yeah, Gil will be able to. Never mind. Yeah, so if you put the Herodotus API key by signing up the GitHub, then you can get the Herodotus API key and you copy paste to the Herodotus API key and then you send it. Then you can able to generate the proof, which is you can read it you generate the proof based on Gorilli, block number this, to the Starknet, and the specific property that you ask is block number and proposer. Yeah, that's how we use the API. Yeah, I think that's almost all. So thank you for listening. Do you have any questions for? Yeah, I have 5 minutes. So if you have any questions, then yeah, thank you. Oh yeah. If you can, then yeah, you will be cool. Yeah. Thank you. If you have any questions about Herodotus, then yeah, in the meantime, you can go ahead. Yeah, we got one more user in the Herodotus. Generate the proof, and you can get the task ID, which is you can call the status of the task ID. And right now, our API is a little bit slow. But we are optimizing and also doing auditing, and then yeah, we are changing a lot of stuff based on the talk that we do at the SF, borrowing the sharp. So later it will be 5 minutes-ish, then it will process all. I think there's a question, so thank you for listening.